Now on page 617, page number 617, they're talking about everything you mix into it doesn't mean that everything inside the solution has to be dissolved. Like example, when you see the ocean water, it's a solution, but it contains several different dissolved substances and undissolved also. A mixture of sand and water. Do you think that sand and water they dissolved? No. From where waves wash over the sand, such a mixture is not a solution. Understood? Like sand and water, is it a solution? No. Something what dissolves inside is called a solution. A solution forms when one substance dissolves in another. It has to dissolve completely, like I have shown you before the example of blue and green color solution. Now, when something dissolves, it breaks up into particles so tiny that they can't be seen even with a microscope. They evenly inside, they get mixed, especially in the solution. They evenly mix with the other part of the solution. Now, if you put a rock and a salt in water, salt will dissolve, but the rock won't dissolve. Now, solutions are commonly liquids, such as the mixture of different liquids that make up gasoline. They have given you an example here. Solid solution form in solid copper and solid zinc. These are different elements. Solid copper, solid zinc, like example gold, silver. So they're talking about that. You know that air is a solution of different gases. What does air contain? It contains gases of nitrogen, oxygen, carbon dioxide. They are evenly mixed. Okay, so here we are talking about the mixtures of the dissolved and undissolved substances. Now, I told you about, please read them out later and highlight it. Same thing, it's there. A mixture of sand and water forms when waves wash over the sand. Such a mixture is not a solution. Same thing what I taught you before. But I've taken out the important points so that you can highlight it reading it here. All right, here. So separating mixtures. Mixtures are not always easy to separate. I know the magnets, okay, magnet or iron and some other, like example, I remember in my lab, iron and sulfur. So it was very easy for me just to take a magnet and remove iron from sulfur. But always things are not easy. Physical properties such as color, size, melting point, boiling point, density, and ability to dissolve can be used to separate. Girls, when it's just color, like example, I give you, you know those mini chocolates? I give you a box of mini chocolates, or what is that, M&Ms, and I told you to separate different colors. You can easily do that because of colors. But sometimes colors are the same, but you have to check with their different things, different physical properties. So we are talking that physical properties are color, size, melting point, boiling point, density, and ability to dissolve can be used to separate mixtures. What property was used to separate items on this tray? What do you see here? Shapes or colors? Here they are taking the circle and here the cubes. So of course shape. And you can also write shape and color. Color is also not wrong. But we see in this tray, they haven't put those pink together, yellow together. They have just separated with their shapes. So that's why shape is the answer. Now density, every substance has its own density. A less dense substance will float on the denser substance. Object will float in water. If you know, like if they see that, they check the density, which one is more denser, which one is less denser, and what will sink and what will come back. So this is for today's class. I hope it was interesting and you understood my lesson. Inshallah, by tomorrow we'll continue. Take care of yourself till that time. And please, girls, stay safe and don't forget, help your mom today. Bye-bye. Take care, girls.